missing side length using similar figures. Alright, go ahead and copy down this picture. This right here says triangle. This is triangle. ABC is similar. This little squiggly mark means similar to DEF. And we have to find the length of DE. So we have to find this length right here. Okay, so what you should notice is that these two triangles are not oriented or facing the same way. We have this obtuse angle here. It's sitting on the bottom, but the obtuse angle on this triangle is on the top. So what we have to do is flip one of them around so that they're both facing the same direction. So if I had a duplicate over here, I literally would I like to turn the smaller figure to face the same direction as the larger figure. So do you see, so here is DEF, and what I'm going to do is I just flipped it over to where now DEF is facing the same way. So you're going to redraw every single time. I need to see that you have redrawn your picture. So what I would do is I like to redraw, like I said, the smaller one. So I'm going to draw another triangle just like ABC. So I basically took D and I flipped it around. So D is now right here. And then E is now at the top. And then F is over here on the side. So then what you're going to do is actually scratch out your old one so you don't get confused. Oh, don't forget to label. So here is 5. Alright, now we have to find the length of DE. So we're looking for this length right here. So you should be able to see that to get from 10 to 5, you divide by 2. You're dividing by 2. So if you want to talk about scale factor, remember scale factor is what you always multiply by. So the scale factor from big to little is not 2. It's 1/2. Because we take 1/2 of 10 to get 5. So scale factor is one way that you can find the missing side length. So then we could take 6 and we could either multiply it by half or divide it by 2 to get 3. So that is one way to find the missing side length. But the other way, and what I suggest, is using a ratio table. So what you're going to do is draw a ratio table, and I'm going to put ABC here, and then I'm going to put DEF right here. So on ABC, I'm going to start with 10, and that corresponds to 5 on DEF. And then on ABC, 6 corresponds to the side that we are looking for. So I'm going to put my box or a question mark or an X. So you could scale 10 to 6. You could get it down to 2 and then back up to 3. Or you can scale directly this way, divide by 2, which I understand is the same thing that we just did using scale factor. But if you use a ratio table, then all of your information stays nice and organized. So DE, side length DE is 3 centimeters. Alright, so go ahead and copy this one down. These two triangles are similar, so this large triangle is similar to this small triangle. We have to find this side length right here, D. So copy this down, and we will solve together. So again, the first thing that you want to do is redraw one of your shapes so that they're facing the same direction. And I'm going to again choose the small triangle to redraw. So basically I took my right angle and I flipped it around so my right angle is now right here. And so my side length 18 feet is now at the bottom, and 20 feet is now my height. So you could figure out how to get 90 to 18, or actually 18 to 90, because you want to get 20 over here to D. So you could do that by dividing, but let's go ahead and set up a ratio table. So I'm going to put, and I'm going to label, I'm just going to say small triangle to large triangle. So on my small triangle, I've got 18, and that corresponds, I forgot to scratch this one out, that corresponds to 90 on the large. And then I've got 20 on the small, which corresponds to D, or my box, or whatever you want to call it. So now we have to figure out either how to get 18 to 90 or 18 to 20. So you may know that 18 times 5 is 90. So then you can multiply 20 times 5. If that doesn't pop out to you immediately, you can scale down and to scale back up again. Okay, so I'm not sure that actually recorded. I would divide 18 by 9 to get 2, and then 90 divided by 9 is 10, and then 2 times 10 is 20, and then 10 times 10 is 100. So side length D equals 100 feet. So pause, watch the video as many times as possible until you understand it. And then understand that you can either use scale factors or a ratio table, which essentially you're doing the same thing. You're still using scale factor. With a ratio table, it's just a little bit easier to organize information in a ratio table. Which strategy do you prefer, or is there another strategy that might work better for you? If so, I would love to know what it is. This is so important. Don't forget to reorient the figures so that they're facing the same direction.